Now we discuss about the intensity of the reflected and transmitted wave uh, when the electromagnetic wave is incident normal to the interface. We know the intensity, which is the average power per unit area or average energy per unit time per unit area. Average energy per unit time per unit area. Intensity that is given by half epsilon, the permittivity, v its velocity, the velocity of the wave in the medium, E0 square, the electric field amplitude square. So this is the intensity. Okay. So the reflection coefficient. Reflection coefficient is the fraction of incident energy that is reflected. Okay, the fraction of incident energy that is reflected. So that is calculated as IR by II. IR is the intensity of the reflected electromagnetic wave, and II is the intensity of the incident electromagnetic wave. So that is equal to, by the previous equation, by this equation, half epsilon v E0 square. We have half epsilon 1 V1 E0 R square. Epsilon 1 is the permittivity of the medium 1. V1 is the velocity of the electromagnetic wave in medium 1. And E0R is the amplitude of the reflected electromagnetic wave. That is divided by half epsilon 1 V1 E0 I square. E0 I square. The amplitude of the incident wave. So the reflection coefficient, the fraction of incident energy that is reflected is IR by II, is given by E0 R E0 R square by E0 I square. And we substitute for E0 R. E0 R we know that is modulus of N1 minus N2 by N1 plus N2 E0 I. We substitute in it, so we get R equal to N1 minus N2 by N1 plus N2 square. Okay, so this is the reflection coefficient. Then the transmission coefficient. What is the transmission coefficient? T, that is the fraction of the wave that is transmitted. Okay, fraction of the wave that is transmitted, the transmission coefficient, that is equal to IT by II. IT is half epsilon 2 V2 E0 T square. Okay, II is half epsilon 1 V1 E0 I square. Okay, now for the transmitted wave, the wave traveling in the second medium. Okay, there the permittivity is epsilon 2. There the velocity of the wave is V2. So this is the equation. And here we have epsilon 2 by epsilon 1. We know V1 by V2. V1 is a velocity in the medium 1. V2 is a velocity in medium 2. When V is equal to 1 by root epsilon 1 V1. Okay, V2 is 1 by root epsilon 2 mu 2. Okay. So that is equal to V1 by V2 is root epsilon 2 mu 2 by root epsilon 1 mu 1. And we know mu1 and mu2 is approximately equal to mu or mu 0. The permeability is not much different from the permeability in the free space. So these are equal, and we have see V1 by V2 equal to root epsilon 2 by epsilon 1, or epsilon 2 by epsilon 1 is V1 square by V2 square. We know beta is mu1 V1 by mu2 V2, that is equal to mu1 N2 by mu2 N1. So V1 by V2 is that is equal to N2 by N1 if mu1 and mu2 are not much different from mu. or the permeability in the free space. So V1 by V2 is equal to N2 by N1. So that we substitute. Okay, so T is equal to N2 square by N1 square. What is it? N2 square by N1 square, that is epsilon 2 by epsilon 1 here. Epsilon 2 by epsilon 1. And that we substitute, and V1, V2 by V1. V2 by V1 is N1 by N2, that we substitute. And we substitute for E0T. Okay, E0T, that is 2N1 by N1 plus N2. So E0T square is 4N1 square by N1 plus N2 square. So what we get is 4N1 N2 by N1 plus N2 square. So this is the transmission coefficient. Okay, so we have got the reflection coefficient and the transmission coefficient. And as we said earlier, they measure the fraction of the incident energy that is reflected and transmitted. And what we observe is, when you add R and T, okay, this is T, 4N1 by N2, 4N1 N2 by N1 plus N2 square, and T, the R is N1 minus N2 by N1 plus N2 square. So when you add, you will be getting what? 1. We can see that we will get 1, because both in the numerator and denominator we will have N1 plus N2 square. So we are getting 1. Quite expected, because of the conservation of energy. So when a wave is incident on an interface, a part of it is reflected, the remaining part is transmitted. Okay, remaining part is transmitted. So R plus T, that should be equal to 1 to conserve the energy.